Welcome back again to your Unacademy Neet English channel. I believe all of you are doing great, all of you are doing amazing. And my dear students, in this particular amazing session, which is going to be short and precise, I'll give you all the important reactions of your benzene and benzene diazoxide chloride. Right? My dear students, you can expect a short question from this flowchart, which I have come up with in the today's session. Okay? Dear students, we shall be starting with benzene. Here you have got the benzene, right? The first thing, if you do the nitration of benzene, what do we get? We get nitrobenzene, right? And to do the nitration of benzene, we use concentrated HNO3 plus H2SO4, which is what you call as nitrating mixture, right? So with the help of nitrating mixture, right, benzene gets converted into nitrobenzene, okay? Once you get nitrobenzene, you can do its reduction, right, with the help of tin and HCl, or you can use iron and HCl as well. And when this nitrobenzene undergoes reduction, it gets converted into aniline, right? The most important compound here, aniline. So from benzene to nitrobenzene, from nitrobenzene to aniline. And when you do the diazotization of this aniline with the help of NaNO2HCl, what do we get? We get benzene diazoxide chloride, right? The most important compound. From this benzene diazoxide chloride, you can get everything. My dear students, first of all, the benzene diazoxide chloride, which I got over here, right? If you make it to react with HbF4, what do we get? We get benzene diazoxide chloroborate, right? This benzene diazoxide chloride, it is unstable at room temperature, but this particular compound, it is stable at room temperature. Perfect. And this benzene diazoxide fluoroborate. Perfect. When you heat it up, what do you get? You get fluorobenzene, and this particular reaction is called as Boltzmann's reaction. From the same compound, if you make it to react with NaNO2 copper and give some heat, it gets converted into what? It gets converted into nitrobenzene. Perfect. Right? So from benzene diazoxide chloride, you can get this. From this, you can get fluorobenzene through Boltzmann's reaction, or you can get nitrobenzene again. Perfect. Now guys, from this benzene diazoxide chloride, we can get phenol as well. Perfect. Benzene diazoxide chloride, you have to make it to react with warm water. What do we get? We get phenol. And phenol in presence of zinc dust, it again gets converted to benzene. As simple as that. So from benzene diazoxide chloride, you can get phenol as well. From phenol in presence of zinc dust, you can get benzene again. Perfect. Now, is there any way of converting benzene diazoxide chloride to benzene again? Yes, with the help of these reducing agents. Perfect. Glucose will be acting here as a reducing agent, or you can use C2H5OH, or you can use H3PO2, or you can use SnCl2, right? In presence of all these, your benzene diazoxide chloride gets converted into benzene. Perfect. Now, other reactions of this benzene diazoxide chloride, as you can see over here, in presence of Cu2Cl2HCl, which is what you call a Sandmeyer's reaction. What do we get? We get chlorobenzene over here. Perfect. Again, in presence of copper powder, right, which is what you call as Gutterman reaction, again you get chlorobenzene. Now, from Sandmeyer's reaction, you get a good yield of chlorobenzene. Here you do not get as good yield of chlorobenzene through Gutterman's reaction. Perfect. So that means benzene diazoxide chloride, if it undergoes Sandmeyer's or Gutterman's reaction, it gives chlorobenzene, but the best yield is provided with the help of Sandmeyer's reaction. Perfect. Now, again this benzene diazoxide chloride in presence of what? CuBr to HBr, which is what you call a Sandmeyer reaction. Perfect. Or you can use copper in presence of HBr, you can call it as Gutterman reaction. What do we get? We get bromobenzene. We get bromobenzene through these two reactions. Remember the reagents, CuBr to HBr, Sandmeyer. CuHBr, Gutterman. Perfect. Now, the same benzene diazoxide chloride, if you make it to react with CuCN, KCN, again you call this a Sandmeyer reaction. What do you get? You get cyanobenzene. And my dear students, from this cyanobenzene, you can get benzaldehyde as well. Perfect. You just need to make this cyanobenzene to react with SnCl2HCl, right? This is what you call a Stephan reduction, and with the help of Stephan reduction, you can get benzaldehyde as well. Perfect. So look at this particular chart carefully. all the important reactions of your benzene, benzene diazoxide chloride, right? You have mentioned over here. So again, from benzene, nitrobenzene. From nitrobenzene, do its reduction. What do we get? Aniline. When you do the diazotization of aniline, you get benzene diazoxide chloride, right? From benzene diazoxide chloride, you get benzene diazoxide fluoroborate, right? From this, you can either get fluorobenzene or you can get nitrobenzene, depending on the reagents which we use. Again, is there any direct method of conversion of this benzene diazoxide chloride to benzene? Yes, you just need to do its reduction, right? Perfect. These are all the reducing agents which undergo oxidation. Perfect. And your benzene diazoxide chloride gets converted into benzene. Now, from benzene diazoxide chloride to your phenol, just warm H2O, right? And again, in presence of zinc dust, again you get benzene. And all these are your Sandmeyer and Getterman reaction. Remember the good yield and not good yield in these two cases. I hope I'm clear with this. I hope this particular chart is clear to you. And my dear students, trust me, from this particular chart, you are going to get one question for sure, 100% guarantee I'm giving in your upcoming NEET